Hey everyone, welcome. Today we're just working on a single problem because this question is quite a difficult one. So we're going to work on this problem called defective ball. So this question says you have 12 identical balls, however one ball is heavier or lighter than the rest. We don't know which one it is. So we have a balance that can only show which side of the tray is heavier. So a balance is something like this. You can measure two things. It'll show which side is heavier, either the left side or the right side. The balance can also be the same. For example, the left side and the right side, they have the same weight. So using this balance that can only show which side of the tray is heavier, how can we determine which ball is defective with only 3 measurements? So which ball is the defective one with only 3 measurements? So right off the bat, a common idea is to use the first measurement to measure half of the balls on one side and the other half on the other side. So a common idea is to measure balls 1 to 6 on one side and balls 7 to 12 on the other side. So what information does this measurement actually give us? So suppose the left side is heavier. So if the left side is heavier, that means one of the balls from 1 to 6 is the heavier ball. So if the right side is heavier, then one of the balls from 7 to 12 is going to be the heavier ball. But also, it could be that one of the balls from 1 to 6 is the lighter ball. Or in the first case, if the left side is heavier, one of the balls from 7 to 12 is the lighter ball. So this doesn't give us too much information. It gives us, splits the balls into 2 sections and says, hey, one of the sections has a lighter ball or the other section has a heavier ball. So is there another way for the initial measurement to give us more information than this? There actually is. And that way is to split the balls into 3 groups. So 12 is divisible by 3, so we can split it into 3 groups of 4. So let's see what information we get from measuring 3 groups instead of 2. So we can measure only 2 groups at a time. So let's say we measure the groups 1, 2, 3, 4. This is on one side of the scale. And on the other side, we're going to have 5, 6, 7, 8. So there's going to be 3 different situations. First, the left side is going to be heavier, or they're going to be the same, or the right side is going to be heavier. So any of these is possible. If the left side is heavier, what does that mean? That means one of the balls in 1, 2, 3, 4 has to be heavier, or one of the balls in 5, 6, 7, 8 is lighter. So if the balls are equal, what does that mean? So if the weight of these 2 groups are equal, that means one of the balls in 9, 10, 11, 12, these are the balls that we didn't measure. One of these is either lighter or heavier. If the right side is heavier, in this case, that's actually the same as the left side being heavier, it's just reversed. So because the balls are labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, the balls are actually symmetrical, so we can actually swap the labels around. So let's say we always assume the left side is heavier or they're equal, because if the right side is heavier, we can swap the labels of the balls in 1, 2, 3, 4 with the balls in 5, 6, 7, 8. So now we're only left with 2 possibilities because without loss of generality, the left side and the right side being heavier is the same. So now we have two different cases. One case where the left side is heavier and one case where the right side is. One case where the balls are equal, which means the unmeasured balls are either lighter or heavier, or that they're defective. So what should we do now? We have this situation, so we know one of the balls in 1, 2, 3, 4 is heavier, and one of the balls in 5, 6, 7, 8 is lighter. So what we want to do is we want to split it into three groups again. So there's 8 balls here, so we can't split this into 3 groups. So we need to take a ball. For example, we take the 9 ball and we add it to here. So we know this 9 ball is guaranteed not to be defective because one of the left side or the right side is heavier in this case. So 9, 10, 11, 12 have to be a neutral, normally weighed ball. So we know 9 is not defective. So how should we arrange the groups? So can we say something like this? We weigh 1, 2, 3 versus 5, 6, 9, where 9 is not defective. So let's say we have this weighing. So suppose the left side is heavier. Is that possible? Yes, that's possible. One of the balls in 1, 2, 3, 4 is heavier than the other. So suppose the left side is heavier, then we have a lot of different possibilities here. If the left side is heavier, 1, 2, 3, all of these could be the heavier ball, or 5 or 6 could be the lighter ball. So we have a lot of possibilities here, and we have a single weighing left. So we can't find which ball is defective out of 5 balls with a single weighing. We can only find from at most 3 balls. So this arrangement doesn't actually work. This is because only the left side can be heavier. The right side cannot be heavier because 5 or 6 are guaranteed to be the lighter balls. So how should we take advantage of the fact that the right side can also be heavier? Well, an easy way to do that is to swap the balls 5 and 3. So we can erase all of this here. What we're doing is swapping the 5 to be on the left side and swapping the 3 to be on the right side. This way, both the left and the right sides can be heavier, so we have more cases to analyze. So now, suppose the left side is heavier. So what does that mean? That means either 1 or 2 is heavier. 5 can't be heavier because we know 5 is in the lighter group. 5 is guaranteed to be a lighter ball or a neutral ball. So we know either 1 or 2 is heavier, or it's possible that 3 is lighter. So now, what if these are equal? Well, that means 1, 2, and 5, all of these are good. 3 and 6, those are good. So which balls did we not measure? We didn't measure 4, 7, and 8. So we didn't measure these here. So either 4 is heavier or 7, 8 are lighter. So what happens if the right side here? If the right side is heavier. So the right side has 3, 6. Only 6 is a possible heavier ball. And if the left side is lighter than the right side, that means 5 is a possible lighter ball. So either 5 is lighter or 6 is heavier. So there's only 2 options here. So what should we do in each of these cases? So suppose 1 and 2 are heavier in this case, and 3 is lighter. How should we weigh them? Well, we can weigh 1 and 2 against each other. So we're going to weigh 1 against 2. So there's 3 different cases again. So suppose 1 is heavier, that means 1 is the heavier ball because both 1 and 2 are heavier or normal. So if 1 is heavier than 2, that means 1 is the heavier ball. So if the left side is heavier, the 1 is heavier, that means 1 is a heavier ball. And we found the defective ball. If these 2 are equal, so 1 and 2 are both not defective, that means we're only left with 3. 3 is a lighter ball and 3 is defective. So if the right side is heavier, that means 2 is heavier than 1. 1 or 2 are both heavy or neutral balls, so we know that 2 is a heavier ball. So in all these cases, we're able to find which ball exactly is defective. So now moving on to the second situation here, 4 is heavier or 7 or 8 are lighter. So just like the first case, we can weigh 7 versus 8, and that's going to give us 3 different cases again. For example, the left side is heavier, they're equal, or the right side is heavier. So in this case, we're saying which one is lighter. 7 or 8 are both possibly neutral or lighter balls. So if the left side, if 7 is heavier, that means 8 is the lighter ball. So 8 is lighter. If they're equal, that means 4 is defective. 4 is the heavier ball that we didn't weigh here. Or if the right side is heavier, that means 7 is a lighter ball. So in all of these cases here, we also find which exact ball is defective and whether it's heavier or if it's lighter. So what about this case? 5 is lighter or 6 is heavier. If we weigh 5 against 6, we know that the 6 side is always going to be heavier, but we don't know if that says the 6 is defective or the 5 is defective. So instead, we can weigh these balls against a neutral ball. So for example, we can weigh the 5 ball versus 9. So 5 is a possible lighter ball, so it's not possible that the 5 side is heavier. So suppose they're equal. So if 5 is the same as 9, that means they're both not defective because we know 9 is not defective. So that leaves us with 6 being defective, and 6 is a possible heavier ball. So on the other case, so suppose 9 is heavier, so the right side is heavier. That means 5 is a lighter ball because 5 is lighter than a normal ball. So 5 is lighter in this case. So with that, suppose one of the sides is heavier. Like in this case, we're able to find exactly which ball is heavier or lighter with only 3 measurements. Because this is the first measurement, this is the second measurement, and these are the third measurements. So now we still have another case to deal with. We have the case where 9, 10, 11, or 12, those balls are heavier or lighter. So how do we group these and how do we compare these? So we can take some of the balls in here and compare it with each other, but we don't have enough to form 3 groups. We only have 4 balls here. So we should take a ball that is neutral. So if the balls in 9, 10, 11, 12 are heavier or lighter, that means the balls in 1 to 8 are all guaranteed to be neutral. So let's just take 8 for simplicity's sake. So 8 is a ball that we know is not defective. It's a neutral ball. So let's weigh 9 and 10 versus something like 8 and 11. There's lots of different ways to weigh these because this is a rather simple case, and many different weighing options can all give us the answer. So this is just one of the ways we do this. So we weigh 9 and 10 versus 8 and 11. So either 9, 10, or 11 could be lighter or heavier. So it's possible that the left side is heavier. So if the left side is heavier, what does that mean? That means either 9 or 10 is heavier or 11 is lighter because we know 8 is neutral. So we have 9 or 10 is heavier or 8 is lighter. So could this be equal? This could also be equal because we still have a ball that we didn't measure, 12. So if these are equal, that means 9, 10, and 11 are all neutral, which means 12 is defective. So in this case, we just know 12 is heavier or 12 is lighter. So finally, in the last case here, it's possible that the right side is heavier. If the right side is heavier, either 9 or 10 is lighter or 11 is heavier. So we have 9 or 10 is lighter or 11 is heavier. We don't have a lot of space here, so let's actually move this case down and examine this. Let's make it a little bit bigger. Nice. So in the case that 9 or 10 is heavier, just like the previous examples, we can just compare 9 or 10. So we're going to compare 9 versus 10. So if 9 is heavier, if the left side is heavier, that means 9 is the heavier ball. So 9 heavier. So if these two are equal, that means they're both not defective, which means 8 is defective. 8 is the ball we didn't measure, and 8 is a possible lighter ball, so 8 is lighter. So if the right side is heavier, that means 10 is heavier. 10 is heavier. Again, with exactly 3 measurements, we're able to see which ball is heavier and which ball is lighter. So now, with the case that 12 is heavier or 12 is lighter. So how do we know if 12 is heavier or lighter? Well, we can compare it with a ball that we know is neutral. We know that 8 here, 8 is guaranteed to be neutral. So we can compare 8 with 12. So 8 versus 12. So there's only 2 different cases here. There's the case that 8 is lighter, so the left side is heavier, in which case we know that 12 is a lighter ball. Alternatively, the right side is heavier, so 12 is a heavier ball. So again, with 3 measurements, we're able to determine 12 is the ball that's defective, and we can determine if 12 is heavier or lighter than the other balls. So finally, in the last case here, we can compare 9 and 10. They're both possibly lighter balls, but we want to know which one. So if the left side is heavier, 9 is heavier, that means 10 is the lighter ball. If they're equal, then the ball that we didn't measure, 11, is the defective ball, and 11 is a possible heavier ball, so it has to be heavier. So if the right side is heavier, that means 9 is the lighter ball, because 9 or 10 can only be lighter balls. So 9 is lighter. So again, with 3 measurements, we're able to determine exactly which ball is heavier or lighter. So let's just move this back. Nice. So just like the previous case, this is the second measurement and this is the third measurement. So with 3 measurements, and I'm running out of space here, but we're able to determine which ball is defective and which ball is heavier or lighter. The question only actually asks us which ball is defective, the defective one, but we also determine which is heavier or which is lighter. So that's it for this question. This question was quite a difficult one because it took a lot of out-of-the-box thinking here, where we had to split into 3 groups, and then after we split into 3 groups, we have to again try to group the balls into groups of 3 to compare which one is heavier or lighter. So with that, we could determine which ball is defective with only 3 measurements. So thank you guys so much for watching. Hope you're able to learn something, and I'll see you in the next video.